Hello and welcome to lesson 7, where we're going to focus on word problems with inequalities. If you shied away from word problems and equations, this will be pretty difficult. If you practiced those and got better at them, this will be a little bit easier. It's not going to be easy, but it'll be easier. I want to point out the learning targets real quick. Setting up and solving word problems involving inequalities, pretty obvious. But the second one, that's the tricky part. And we'll get to that here in a little bit. So in writing an equation from a word problem, I kind of give you a general template to set up your inequality. It's going to help you with the setup. First thing is write an algebraic expression to represent the actual amount of what you're doing. So this will make sense when we get to the first example. The second thing is write an expression to represent the other side of the inequality. Many times, this side will be a number. But there are times when it will be more, but a lot of times it's going to be a number only. So it's going to be an easy step to skip, okay? And then the third thing, last thing before you solve it is determine the symbol to put between the two expressions. That's where the reasoning comes in. You got to think here. The first two hopefully are pretty easy, okay? And the last ones we have to think, all right? Let's get started with some examples. Johnny wants to spend no more than $500 on a new gaming system and some games. The game console costs $249.99 and each game costs $35. Find the possible number of games Johnny can buy. So a lot of people go straight to the inequality part, step 3. Wants to spend no more, and they start thinking about that. Don't. Expression number 1. Let's look at, okay, how much is it going to cost him? And write an expression for that. Well, we know what's going to go into the cost. $249.99, right? That's how much the console costs. Plus $35 per game. X is the number of games. Expression number 2 is 500. Now, what I want you to see is $500 is not what he's spending. That's his limit. It's not what he spent. It's how much he's willing to spend. Above 500, he's not happy. Below 500, okay, he's good. Okay, so 500 is not a solution. It's the boundary. This is an inequality. All right, so now we're going to set the two expressions on other sides of the inequality. So $249.99 plus 35x, and we're going to compare that to 500. So this part on the left is his actual spending. This is your boundary or your goal. So does Johnny want to go above and be greater than 500? No, he wants to be less than 500 or equal to. He's willing to go with 500 exactly. Because he's willing to go exactly, that's where the equal to comes in. There's the setup. You're done with the hard part, except at the very end. So now we're going to solve this. 500 minus 249.99 is 250.01. It's on that side. So I got 35x. So I'm going to divide by 35. And I get a disgusting number. And that's where this gets a little tricky. It's x is less than or equal to 7.14, blah, 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 blah. It's a big decimal. Now, let's look at that. X is the number of games. Games cannot be sold in partial segments. So it's got to be a whole number. What is the largest whole number that I could put in for X and make that a true statement? Well, 7, right? 7 would be a good number of games. If I go to 8, then I'm going to spend more than $250 on games. And I'm going to spend more than $500 on everything. All right. So what I'm going to do is I'm going to say that X has to be less than or equal to 7 games. I've got to take the number that I get and I've got to interpret it in the context of this problem. So he can buy 7, 6, 5, 4, 3, 2, 1, or no games. That is putting it in context of the problem. We're going to practice that some more with more examples. On a hunting trip, Taylor's goal is for him and his dad to get at least 35 rabbits. Taylor gets, on average, 3 rabbits per hour, while his dad gets 16 rabbits total. Find the possible number of full hours Taylor needs to hunt to reach his goal. So we're looking for full hours. So we'll use H for number of hours. 35 is the goal. That's expression number 2. So expression number 1 is actual. Expression number 2 is goal. So the goal is 35. The actual, well, his dad got 16. He knows that. His dad's going to get 16. Taylor's got to cover the rest of that. So plus, but he gets 3 per hour. And we're looking for how many hours it's going to take to get to 35. So there's my 2. So 16 plus 3H and 35. They want to get at least 35 rabbits. So 35 is the smallest number that they want. All right. So the actual number of rabbits they want to be bigger than 35. They'd be okay with exactly 35. So greater than or equal to is the symbol that we're going to use. Notice how I didn't think about which symbol until I was done with the expressions. Now I can solve. Subtract 16. I get 3H is greater than or equal to 19. H is greater than or equal to 6.3 repeating. Yep. Okay. So now I got to think about that. It says find the possible number of full hours. 0.3 is not a full hour. Rounding would say round that down to 6. And in this case, it actually does work that way. Actually, no, it doesn't. If I round that down to 6, 6 would not be enough, right? I want the number closest to 6.3, the closest whole number to 6.3, that's going to make that true. So it's basically either going to be 6 or 7. 6 is not going to make a true statement. 7 will. 7 is greater than or equal to 6.3, right? That's the first whole number that makes this true. So his hours that he has to hunt is greater than or equal to 7. So he's got to hunt for 7 hours or more to get his goal. That's where the interpretation comes in. All right, 4 more than triple a number is greater than 8 less than 5 times the same number. Find all possibilities for the number. All right, so this one, a little different than the first two because our goal, or our expression number 2, is not a number here. Expression 1 is one side. Expression 2 is the other side. Is greater than is my separator. So the left side is over here. And the right side, where number 2 is over here. So the left side, 4 more than triple a number. Triple a number is 3n. 4 more than that is plus 4. Is greater than 8 less than 5 times that same number. 5 times that same number would be 5 times n. 8 less than that would be minus 8. Now, the good news here is when I write this out, it tells me what sign to put. Is greater than. Got a sign for that. Find all possibilities. So now we're going to subtract 3n, just solve it like we've been doing. I get 4 is greater than 2n minus 8, add 8. This one works out nicely, which is great. So I get 6 is greater than n. I like to write my variable first. In this case, n is less than 6. So any number less than 6 would work with this description. Pretty easy one there, because you don't have to really interpret the solution. It's a nice whole number. Last one Sherry started a business designing and selling custom t-shirts. The equipment she needed cost $4,700. She buys the plain t-shirts for $3.20 each. She then sells the newly designed t-shirts for $19.99 each. For what number of t-shirts sold will Sherry make a profit? Well, first of all, I want to talk about what profit means. Profit means that your money made is greater than your costs. So this is going to look a little different. So money made, we're going to write an expression for money made for Sherry. And we're going to write an expression for cost. Well, she's making money by selling the t-shirts. So that's this part right here. She sells them for $19.99 each. So $19.99 per t-shirt. So I'm going to use X to stand for number of t-shirts. All right. Her costs, well, the equipment is $4,700 or $4,700. And she buys the plain t-shirts. That's a cost. So it's an added cost of $3.20 per t-shirt. All right, so $19.99 X is greater than, I don't have to think about it because I already talked about it here. It's greater than the costs, 4,700 plus 3.20 X. Now we solve, I'm gonna switch colors so you can see a little better. Subtract 320 X. And I get 19.99 X minus 3.20 X is 16.79 X. Is greater than 4,700. Divide. It's not going to be a good number. Tell you that. So 4,700 divided by 16.79, 279.9. What is the first whole number that makes that true? So 280 would be the first number that makes that true. Now, you gotta be careful though, because if I write X is greater than 280, that's actually not correct because 280 would not be a possible solution. So we have to remember with this situation here that I've got to include 280 as a solution. So I'm going to switch it. I know I didn't have an equal to sign, but I'm going to put an equal to sign right there. The other way of doing this would be X is greater than 279. That would be saying the same thing. That's tricky, but I did have to add in because I include 280. I included it, which means I have to add in the equal to. That's where the interpreting the solution and putting it in terms of an inequality can be a little tricky, but we're going to have a chance to practice it. Make sure you're asking in class if you have any questions.